Welcome to the TWIML AI Podcast. I'm your host, Sam Charrington. Before we get to today's show, a quick plug for the TWIMLcon AI Platform's video packages that we've currently got available for pre-order. If you're working in an organization where productivity, efficiency, or scale of your machine learning efforts matters, please hit the pause button and check out twimlcon.com/videos, where you can take a look at what we've got on offer. While I could list a ton of reasons why you should get these for yourself or your team, instead I thought I'd share a few of my favorite attendee quotes. Very, very relevant for my day-to-day work. Practical information for those trying to scale AI in their organization. If you were to plot out quality versus density, this is up and to the right. Pre-order pricing goes away as soon as we get the videos posted, which is likely within a week, so don't miss this opportunity to get a great deal on this amazing resource and, of course, to support your favorite ML and AI podcast. Once again, visit twimlcon.com/videos for more information on individual and team pricing. All right, on to the show. All right, everyone, I am on the line with Aaron Ma. Aaron is in the 6th grade, and he is 11 years old. Aaron, welcome to the TWIML AI Podcast.
Thanks you for having me, Sam.
I really can't explain how excited I am to kind of dive into this conversation. One of your many accomplishments is just the amount of dedication and accomplishment you've invested in learning machine learning. You've got 3 Udacity nano-degrees on the topic, and you've done 80 Coursera courses. Let's just start out by having you share a little bit with us. How did you initially get interested in machine learning and artificial intelligence?
Okay, so first of all, I'm going to talk about how I got started into computer science, first of all. So when I was 5, I got my first computer, which was a hand-me-down from my dad. And it's an iMac 2008 with 2.4 gigahertz and 2 gigabytes of RAM. So at first, I would be doing educational stuff like Raz Kids, Extra Math, Google Classroom, etc. But then one day I thought, how does this computer work? Does it use images, screenshots? So I decided to ask my dad, and my dad said it was based on coding. So I decided to learn coding. So the first language I've ever learned is HTML, which is a great language for building websites. But then I faced a major disastrous problem. It's because if I just use HTML, all I have is black and white. And I want my users on my website to have a rich, detailed experience. So I decided to learn CSS to create a rich story and make it more colorful on my website. And then I learned JavaScript to make my websites more dynamic. And I'm proud to say that the first website I've ever made using HTML, CSS, and JavaScript is my to-do list, which is basically a web app where you can create, delete, insert, remove all of your to-dos. And it's all stored in your browser cache. And also around that time, my dad took me to my dad's coworker's party. So during the party, one of my dad's coworkers brought the materials for s'mores, like graham crackers, chocolate, and etc. So I decided to make myself useful by using those s'more materials to actually make s'mores. So a lot of people ate s'mores because I made them. Then my dad's coworker called Jeremy came up to me and said, "You should make a website if you're so interested in making s'mores." I thought, I should do that because since I'm interested in programming and I also love making s'mores, I should make a website on it. And I decided to call it The Roasting Company.
The Roasting Company?
Yep, The Roasting Company.
Okay.
But then when I told Jeremy that I was going to use HTML, CSS, and JavaScript, he was like, no. You should use Angular. That's everyone's new favorite front-end framework. So the first thing I did when I came home was go to pluralsight.com and search Angular tutorials. And I've learned Angular from industry experts like Deborah Corrado and John Papa. So then I learned Angular and also the Angular router and also Angular material. And also after learning Angular, my dad took me to my first Angular meetup. And I should also say my first meetup. So during the meetup...
And now, when was this? How old were you when all this happened?
So that time I was 9.
Okay.
When I went to my first meetup, Angular meetup. And during the meetup, there was the NativeScript team who came in. And during the middle of the meetup, there was a NativeScript Jeopardy because the NativeScript team was there. So they asked for volunteers to play the NativeScript Jeopardy. And when they asked for volunteers, literally nobody in the entire room raised their hand. Literally nobody. So I decided to raise my hand and volunteer. And 3 more adults came in and joined me. At first, everyone was like, ha ha ha, this is such a joke. But then after answering the first question correctly, which is, what is the NativeScript command line tool called, which I answered T and S, and also answering a few more questions correctly, everyone in the audience was like, and they knew that I could actually program.
Uh-huh.
So one of the people on the NativeScript team called Sebastian Metallic was pretty impressed with me, and he asked me, do you have a Twitter so he could follow me? And I said no, because what could a 9-year-old learn Twitter from? So the first thing I did when I came home from that meetup was going to Twitter and creating a Twitter account. And Sebastian became my first follower. So if you're listening to this podcast right now, thank you, Sebastian.
Shout out. What's his Twitter handle? Do you remember?
I think it's Sebastian Metallic. And then after a few more months of going to more Angular meetups, learning more about Angular, and also learning how to create a great presentation, in August of last year, when I woke up, my dad told me that I should learn machine learning and AI because it is going to be the future. And I've always wanted to be able to keep up with the future. And also the second reason I wanted to learn machine learning and AI was because you can make moolah from it.
So is your dad into machine learning or programming?
He's into programming, but he's not into machine learning AI. He does front end.
Okay.
So the third reason that I wanted to learn machine learning and AI is because we can save lives using machine learning and AI. For example, one day if we have like a machine learning powered robot that could perform surgeries or detect cancer, people who are living in poverty can actually afford cheap medical care.
Mm-hmm.
So basically, everyone can have access to medical care, even people who are in poverty.
Mm-hmm.
So these are the 3 main reasons why I wanted to learn machine learning. So then I went to youtube.com, like every other kid out there, and searched machine learning tutorials. And from machine learning tutorials online, I actually started to learn machine learning, pick up the basics.
What was the first thing that you learned?
The first thing I learned, it was Python.
Okay.
The first thing I learned.
You didn't have any exposure to Python before you started studying machine learning?
Yes. So then from there, after learning Python, I started to learn the types of machine learning, the fields of machine learning, and also Tensorflow. And I chose Tensorflow because it's backed by Google, it's open source and free, and has a large and vibrant community. It's in demand, and it's also easy to use, compatibility across so much platforms. There's also TensorBoard, and also has integrations, auto differentiation, and is even better than PyTorch from research to production. So after learning TensorFlow, I wanted to share my knowledge of TensorFlow to the front-end community because at that time, that's all I knew, the front-end community.
Mm-hmm.
So the problem is that most of the people in the front-end community only knows JavaScript,
mm-hmm.
and they don't know Python. So if they don't know Python, how do they know TensorFlow? So I needed a way to integrate TensorFlow for JavaScript. First, I was like, oh no, I'm going to have to create my own NPM package, and I'm going to have to maintain it, etc. But then, luckily, I Googled TensorFlow for JavaScript. in which I got the result of TensorFlow JS. And I was pretty lucky because they just released it about a year ago during that time.
Mm-hmm.
So I was pretty lucky on searching that one. And since I already know TensorFlow, if you already know TensorFlow when you learn TensorJS, all it takes you is about 30 minutes to learn it. All you have to do is learn how to install TensorJS, how to call some of the core stuff in TensorFlow.js, and you have to learn the differences between the syntax differences.
Mm-hmm.
For example, in TensorFlow, you use print, the default native Python print. But in JavaScript with TensorFlow.js, you have to use TensorFlow.js's print statement and stuff like that.
Let's maybe hit pause there. There's a ton to learn between Python and TensorFlow. Tell me a little bit more about that path. What were some of the things that, you first have to start with simple linear regressions and things like that. What were some of the things that you learned and how did you learn them when you were first getting started with machine learning?
Well, to be honest, most of this, I'm still a beginner in machine learning because there's a lot of math that I still don't know right now. Because there's such a wide array of stuff to learn. So I'm always still learning more about machine learning and linear regression. I'm still learning more about it. But in TensorFlow and also Python, I know how to implement it using basic packages like NumPy, which is numerical numerical expressions in Python, and other Python math libraries. So in general, I'm still learning more about the math behind machine learning. So I'm always learning. So right after learning TensorFlow.js and TensorFlow, in November of last year is when I started to think about my Christmas presents, like every other kid. Because in November of each year, it's always close to the holiday season. And every single kid starts thinking about their Christmas presents. So I was thinking, I want to become a self-driving car engineer, but there's no place on the internet where you can learn it from. But I Googled it, and I found, Google. So I found Udacity's self-driving car engineering nano-degree program, which is the advanced level. And there's also the intro to self-driving cars, which is a beginner/intermediate. So in that time, which was last year, it's November, Udacity is like $1,200 per semester, I think. Yeah. Around that price.
Okay.
Although I think they already lowered it to around $160 per month now. So basically, during that time, it was pretty expensive, and I wanted to save my family some money. So I decided to basically take a look at the intro to self-driving cars to see what they're going to teach you. So basically, saw what they're going to teach you. They're going to teach you Python and C++. So since I already know Python, I decided to just learn C++ to make up for the intro to self-driving cars, so I can save my family some money. So after learning C++, I enrolled into the self-driving car engineer nano program. And 2 days, I think 3 days.
How many courses in that nano degree program?
In the nano degree program, it's not sorted by courses. It's sorted by lessons.
Okay.
So in a nano degree program, I think they have around 60 lessons.
Okay.
Depend on your nano degree program.
Got it.
So about 3 days before the start of my self-driving car engineering nano program, I received an email from the Udacity legal team stating, "We're sorry, but due to your age that you're under 18 years old, by law, we have to legally terminate your nano degree enrollment." At first, I was really frustrated because they're breaking my dream because I really wanted to be a self-driving car engineer. So I Googled on the internet for Sebastian Thrun's email. In case people don't know, Sebastian Thrun is the CEO and founder of Udacity at that time, although he sadly left Udacity in June of this year. So after 2 days of searching the internet, I came across Sebastian Thurn's email, and there's like over 10 emails. So first of all, I'm not going to send spam to him, so I'm not going to send it to all of his emails. So I decided to just send him to his Udacity email, because that's the email he most likely will check every single day.
Mm-hmm.
So after sending him an email, I received an email from him, which stated, "Start and finish and you make my day." And then Gina, who's an employee at Udacity, actually CC'd the Udacity legal team, which meant that the legal team had to hire a lawyer to write a form stating that I give my child Aaron permission to use Udacity services, etc., etc. And so in January of this year, that's when I basically started the self-driving engineer nano program. So in the first term, and out of 2 terms, because Udacity sorts their content by terms. So in the first term, I learned about perception, localization, and computer vision. And although I didn't make the February deadline, I made it into the March deadline, which meant I could enroll into term 2.
Mm-hmm.
So in term 2, I actually learned functional safety, control, path planning, and also building a real self-driving car using the Robotic Operating System, or ROS for short. So in June of this year, June 18th, I should say, of this year, that was the last day of which I was supposed to graduate. On the morning of that day, I saw that I sent emails to Udacity's graduation team, but I still didn't receive a reply. So I decided to drive there to Udacity's headquarters. So at the headquarters, basically, I told them that I already completed all of the projects, all of the hard stuff, and that I already sent them 3 emails to the Udacity graduation team, but I didn't receive a reply. So basically, they helped me by using their email, Udacity email, to send it to the Udacity graduation team. And about like 5 minutes later, after sending that email, basically they said, "Congratulations, you graduated from Udacity Self-Driving Car Engineer Nano program." Wow. And I was really excited. And during my time at the Udacity headquarters, I met the David Silver, who is the content creator of the Udacity Self-Driving Car Engineer Nano program, and also the lead of the House of Autonomous Systems at Udacity. I also saw Vienna Harvey, who's the owner of Udacity's own self-driving car, which they all call it Carla. And during my experience on their self-driving car called Carla, I was able to get hands-on with the car. For example, I set up the camera, the LiDARs, the radars, and also running scripts on it, and also taking a look at the LiDAR stuff, and also basically checking out the code that they have written. And to me, I think it's like a wow when you take a look at the car.
Can you share a little bit of what you learned in the first semester of that nano degree? You mentioned that you were studying perception and localization and vision. And I know there's a lot of math in those classes that you probably didn't get into, but what were some of the main things that you were able to take away from the class?
The main things, well, I'd say, for example, in the computer vision part of the first semester, they taught us about undistorting images, which I've never heard of before, because all I knew was like cameras are the best because, for example, you can see everything with cameras, but they said no, you can't see everything with the cameras. Originally, everything in cameras is already distorted, so you actually have to write an algorithm for undistorting images. So they did teach us the algorithm for undistorting the images, and they taught us how to write code for it. Well, actually not writing code, just teaching us how to import the CB2 library, which already handles the undistort algorithm for us.
Okay.
And for the perception part of it in the first semester, I'd say I learned about all the different sensors that comes with perception. And also, what's perception? Perception is basically like connecting all those sensors together and fusing them. Which I also learned how to fuse all of that data together. And for localization, I learned how to basically what localization is. And they taught us that localization is basically comparing the objects around the car using LiDAR with the objects in high definition map. And you have to use localization for self-driving cars because high definition maps has about 10 centimeters or more of errors. And when you're building a self-driving car, you can't afford any errors because by the time that you already fix those errors, or you don't even fix those errors, it's going to be too late. You're probably going to collide with objects or something.
Mm-hmm.
So you're going to have to use localization to make sure that you have 1 centimeter of error or less.
Mm.
So
And did you learn like different localization algorithms, or is there just one way to do it?
we learned about common filters, extended common filters, and also unscented common filters. And I think my favorite would be, I'd say, the unscented common filters.
Unscented, like smell? What?
Unscented is basically better than scented because it's kind of, to me, I think it's more faster. So because when you're developing self-driving cars, you want it to be as fast as possible. Because if it's going to be too slow, then you're going to face a huge list of problems, and cars not going to be able to respond in time. So to me, I think the unscented common filters is the best.
And so what is a common filter doing? How does that help you localize?
Well, it's basically just comparing the LiDAR measurements to the high-definition map. And if it's too far or too close, then it knows it's in the wrong place, and it's going to have to reposition itself with the control, which I learned in the second semester.
Got it. So the first semester was all about trying to figure out where the car is, and the second semester is all about controlling system,
path planning, and building a real self-driving car with RAWs.
In the first class, when you're doing the perception and the common filtering stuff, like, are you doing that in notebooks or IDEs, or are you doing it with like actual cars or simulations? What were some of the things you were using?
So in the computer vision part, we use Jupyter notebooks because it's basically like the industry standard right now.
Mm-hmm.
And for the perception and also the localization, also for term 2, we basically use VS Code.
Okay.
So instead of using Jupyter notebooks, we basically switched to Visual Studio Code and to Terminal.
Okay. Cool. So tell us about the second semester.
So during the second semester, I learned about control and basically how to control the car. And for the controlling part, we actually got hands-on with a simulated environment to basically control a car in the simulated environment. Although after trying multiple times, my car still would like jerk left to right sometimes. But overall, I think it was a pretty great experience. But after about 55 tries or something, I finally got it to be got it more precise.
Okay.
Finally driving straight instead of jerking left and right.
Now, I was a lot older than you when I was learning about control systems. I was in grad school, and it was mostly analog stuff, if I remember correctly, like PID controllers. Is that something that came up in your class?
Mm-hmm. Proportional integral derivative.
Right. Is that tech used in self-driving cars? Sounds like yes.
It's yes, although people are now developing better control algorithms.
What are some of the better ones?
So far I haven't heard any of them, but I have heard that people are trying to develop them.
Got it.
Because it's still like really hard to develop something new.
Uh-huh.
Because like right now, self-driving cars, it's really hard to develop because you have to ensure the safety, reliability, and a bunch of different factors.
You mentioned that functional safety was one of the topics. What does that mean?
Basically, safety of your vehicle.
Mm-hmm.
Learning about how to make your vehicle really safe, and also legal stuff. For example, if you're going to build a real self-driving car, you're going to need to create a functional safety PDF file, where we learn about ISO 26262, which is basically the functional safety standard of autonomous vehicles.
And how about the path planning piece?
The path planning. Well, we basically created a proportional integral derivative controller, which would drive in a highway, which could drive by itself in the highway. And for the final project, the Capstone Project, which was build a real self-driving car, we had to form like a team. So I signed up to become a team leader, and like within 24 hours, like over 10 people wanted to be in my team. So I had to like cut about 5 or 6 people because there's a team limit. There's a limit of how many people can be in your team.
Okay.
So in my team, I assigned everyone to their unique role. So I was the person who wrote the ROS code because I'm good at ROS. And I assigned one person to work on the functional safety, one person on writing the README file on how we created it, and also another person writing the README file for the ROS, how we linked our ROS nodes together.
So had you already been exposed to ROS prior to the
Yes.
course, or did you learn it in the course?
I've been exposed to ROS before the course even happened.
Okay.
Like around February 2018. That's when I started.
How did you get connected to or find out about ROS?
Because in February of 2018, I had this really crazy idea of building a robot.
Okay.
Though it never actually happened, which is pretty sad because first of all, you need $100,000 to build a robot, and then you need buy all of these hardware components, and then you have to wire all these up, program all of these, and test it and sell it to users for profit.
So you wanted to build a big robot?
Yep, like a robot that could like help you in your household or something.
Oh, wow.
But
wow.
right now, I can only test it in simulators.
Yeah.
Because it's too expensive to build like a real robot with hardware and stuff.
Have you ever built any small robots?
I've built an Arduino robot.
Okay.
But the problem is that I accidentally bought the wrong wheels, so it could only go forward. So it couldn't turn left or right, which was a bad choice in the making.
I think the robots are a lot more interesting if they can turn, right?
Right. If it can't turn, eventually it's just going to collide with some object.
Cool. So you're second semester, functional safety, path planning, Capstone Project. What was the Capstone Project?
The Capstone Project was building a real self-driving car.
Okay.
That's just what Udacity likes to call it, Capstone Project, to make it like more engaging for people who want to enroll in the nano-degree program.
Got it. And this is a simulated self-driving car, I'm assuming?
Yes, all simulated because if you're building a real self-driving car with ROS, then you're gonna have to buy some sort of software ROS for self-driving cars or something. So Udacity doesn't want us to like pay for like a real self-driving car stuff, so they just basically created a simulated environment for us.
And so, how did the Capstone Project turn out?
Pretty good. It turned out pretty good. Like we passed all of our projects, but there's only one problem. It's that I signed up my team up for the lottery to test our code on a real self-driving car for Carla. Because Udacity has this sign-up form where you can basically test your ROS code on their autonomous vehicle called Carla.
Mm-hmm.
So they've already paid for the ROS middleware for real self-driving cars.
Okay.
So they already put it on their car. They've already set that up. So all they have to do is put your code on it. But sadly, my team didn't win the lottery.
Oh no!
So we never actually had a chance to test it on it.
Oh, that's too bad.
But right now, I'm trying to build a self-driving car that doesn't use ROS.
Okay, what will your self-driving car use?
Well, I'm planning to basically create my own some sort of robotic operating system or something, so I can have more flexibility on it. It's going to be designed and specifically designed and tailored for self-driving cars.
So ROS is used in lots of different types of robots. To your point, not specifically tailored for self-driving cars. What are some of the ways that your operating system will be more suited for self-driving cars?
First of all, I think that I'm gonna make this self-driving car operating system that could basically fuse all of the data together, and also connect all of these nodes of these stuff together, and also make it open sourced. And second of all, I also plan to basically have some sample code ready. So basically, if you only know how to build the hardware part of a self-driving car, basically there's already software written out for you. So all you have to do is put the software on your car, which already has the hardware, which I think is the best way for people to get quickly with self-driving cars. So you don't have to write your own software.
Very cool. I get the impression that that's just one of many projects that you're probably working on or thinking about. Are there others?
There's a lot. In fact, right now I'm also learning how to make a flying car.
A flying car?
Which I don't think is going to be a reality.
Is there a nano-degree specialty for flying cars too?
Yep, the flying car nano-degree program.
Oh, really? And have you started that one?
No. I haven't started that one yet.
So of all of these 3 Udacity nano-degrees, 80 Coursera course certificates, what are your top 3 favorite classes?
Well, my first one would be the self-driving car engineer nano-degree program from Udacity.
Okay.
Okay, my second pick is the AI for trading nano-degree program from Udacity.
AI for training?
Trading.
For trading. Oh, so that's how you're going to fund your self-driving car is through trading.
Investing stocks all day. I'm going to have a bot that's just going to keep buying, selling stocks all day long. And third of all is, I would say, the deep learning AI specialization on Coursera.
The deep learning AI. What are some of the courses in that specialization?
I'm sorry, the deep learning AI Tensorflow specialization.
Ah, okay.
Verification. Tensorflow specialization.
How many classes in that specialization?
There's 4.
And what are they?
So basically, those 4 courses in the specialization teaches you all about TWIML 2.0. So basically, it starts off with videos of really simplified stuff about TensorFlow, and then there's quizzes to enhance your learning, and then they provide a Jupyter Notebook lab environment where they teach you the core concepts of TensorFlow 2.0. So it's basically like this for all 4 courses. And I would say the first course is my favorite because there's actually live interviews from Andrew Ng, who's the founder of Coursera, and also who's really good into TensorFlow 2.0. So I'm pretty inspired by him on the interviews inside the first course of the specialization.
He is a very inspiring individual and contributor in this field. Absolutely. You mentioned that, you go into these courses, a lot of machine learning courses have a lot of math. Some of it is beyond your current ability. How do you approach a course so that you can get something out of it, even when there's potentially a lot that you don't understand? What's your approach there?
Well, my approach to that would be basically, first of all, reviewing the lectures a lot.
Okay.
First of all. And second of all, if I don't know about the math behind it, I would try to basically learn at least how to implement it. Basically, how to implement it using some open source packages. Because there's always an open source package for some sort of math for something in machine learning. So I would try to learn how to implement it. And basically, from there on, after learning how to implement it, I would find some time later on to basically learn the math behind it.
And what's an example of something that you initially, you couldn't get the math behind it? You hadn't seen it before, and you took this approach, and today you understand it because of that approach.
Well, I'd say about the proportional integral derivative, PID.
Okay.
So I basically learned how to implement it in C++.
Okay.
And learn some of the math behind it. Because there's still a lot of math. There's still a lot of math that I still need to learn more about it. But right now, some of it I already understand, and yeah, so I'm always still learning about it.
What parts do you understand now? What parts do you still not understand?
So, for example, the proportional part and the integral part I understand. The derivative, I still don't know how to implement that one, and also the math behind it.
Okay.
I'm always learning, always learning.
Awesome.
I'm never sitting there like relaxing. I'm always learning, always improving every single day.
And do you study math also? What kinds of math do you study, or how do you study it?
I study math. So right now, currently on math, I'm trying to study linear regression if I have the time from it.
Okay.
So I'm found a bunch of great Udacity courses teaching on that particular subject.
Okay. And so all of this amazing studying you're doing with machine learning, how do you balance it with like school and chores and all the things that I'm imagining you also have to do?
Well, I balance it because, first of all, the good thing about school is that they give like not a lot of homework.
Okay.
So basically, I can finish my homework in like 5 minutes. They don't give out a lot of homework
Okay.
these days. And for my chores, I don't have a lot of chores. For example, all I have to do is take the laundry, sometimes wash dishes, clean the table, sweep the floor. Basically, those are my chores.
Mm-hmm.
And after completing them between school and all of my chores, then I have free time to basically study more of machine learning.
Got it. And I think you also have done some Kaggle competitions.
Mm-hmm.
What's your experience been there? How many have you done?
So far I've done 35 Kaggle
35. Wow.
Although, sadly, I haven't won any medals on it. Sad. But I don't really care if I don't earn any medals or anything, because I think it's a really great learning opportunity for me. Because on Kaggle, I can actually learn from my mistakes and also learn from the people who actually won the competition. Because after the competition, I go through their kernels and actually see how they implement their way of doing it. There's also another thing although Kaggle, I learned stuff from it. There's also another thing I don't like about Kaggle. For example, in the free sound audio competition, which ended about 3 months ago. Yeah. So I earned number 1 on the public leaderboard with just one try. Although on the public leaderboard, I was like number 1. On the private leaderboard, I was like at the end, I'm like 393 out of 408 people.
And you were doing the competition while it was still active?
Yes. So I already submitted before they merged. They merged from public to private.
Okay.
So I don't really like how they judge their competitions. Like they only release this little bit of test data set, but most of the test data set they don't release it, which I don't think is very fair. Because, for example, someone who has a really bad model on Kaggle, basically they can go top 100 or something on the private leaderboard. Because your model's bad or something, or maybe good on the unshown portion of the test data set. So that's just one of the things I don't like about Kaggle. But in general, I'd say Kaggle is a great learning opportunity, and I'd recommend it for everyone. Oh, and I also forgot to mention, for people who are interested in learning machine learning but don't know where, go to kaggle.com/learn.
Kaggle.com/learn, good resource for getting started?
Yep, there's good resources for learning Python. Also, there's also an instructor called Alexis Cook who's really good into machine learning. And she has a bunch of machine learning courses on Kaggle. Cool. Free of charge. And also, the content is really, really good. And also, some of the courses were actually made with, in partnership with grandmasters on Kaggle.
Nice. So, what's your favorite type of machine learning?
Well, it used to be supervised learning, but now I definitely say reinforcement learning.
Okay. And why do you like reinforcement learning?
Well, I like reinforcement learning because you can basically do anything with it. For example, if you're training a robot and you're using machine learning for it, you don't need any data. You just use reinforcement learning, and the robot will learn from its trial and error. And after through trial and error, basically every single time it's going to be like really good, and still going to be improving every single day. So basically, you're just going to have to implement your model once, and then you can sit back and relax while you see your robot doing this task that you told it to in your machine learning model.
Do you know what the hard part of reinforcement learning is?
What?
Like figuring out what your cost function is, your optimization function. Do you get into that level of detail with it?
Not yet.
Okay. It's pretty awesome that you even know what it is, though. Do you have a lot of friends who know what reinforcement learning is?
Not a lot. Also, online, there's not a lot of resources on learning reinforcement learning.
Uh-huh.
So I think for reinforcement learning, I still need to learn more about it. There's a lot of stuff I don't know about reinforcement learning.
Have you done any projects with it?
So far, I've only done like 2, I think. Yeah, 2.
What were the projects?
Which was basically finding good bananas in a simulated environment. So there's good bananas and bad bananas.
Okay.
So your task is to train an agent to basically find the good bananas and pick that up and put it into your basket of your good bananas. And don't collect any bad bananas. That's the first project.
Mm-hmm.
And the second project I did was basically train an agent to play tennis with another trained agent.
Like Pong or like real tennis or something?
Like basically real tennis. In a simulated environment, of course. So the simulated environment was provided by Unity. So
Okay.
You only have to train your agent. The other agent is provided by Unity. So you only train one agent. And there's 2 agents in the game, so the other agent is provided by the Unity app.
Well, this has been such a fun conversation. It's so exciting to hear about all the amazing things you've been doing, learning about machine learning and AI. Are there any other things that you want to be sure to share with us?
I would also say after my Udacity nano-degree program, I was also really thrilled and honored to be invited by Lawrence Morney at Google's Tensorflow team, because I became the youngest TWIML contributor, and I basically changed the README. But most of the README on TensorFlow's GitHub page is written by me. So I tweeted it out on Twitter after verifying that. And it was like over 300 likes and 30,000 impressions on the first day. So basically, Lawrence Morney, who's the developer advocate for the Google's TensorFlow project, basically invited me to Google's TensorFlow team to basically learn the ins and outs of how they develop TensorFlow, and also have a chit-chat on the future of TensorFlow. I'm also recently been really honored to be invited by Cruise to Cruise headquarters. So in case you don't know, Cruise is basically a self-driving car company and is based in San Francisco.
Yeah, I actually interviewed the head of machine learning and AI at Cruise at a conference that I recently did. Very, very cool guy. You should listen to that interview.
The TWIML AI conference?
The TWIMLCon conference, yep.
I see. So at Cruise, I basically got to meet a bunch of really smart engineers and talked about how they develop their self-driving cars, and also about how they create their hardware and their sensors.
Okay.
So overall, I think it was a really great learning opportunity for me.
Awesome. You know, I can't believe I almost forgot to mention this. You've also founded a whole bunch of companies: Firebolt Space Agency, Dopey Lopey, and Snap Auto. What are these companies?
So I don't work on Dopey Lopey or Firebolt Space Agency anymore.
Okay.
So right now I'm only focusing on Firebolt Inc. and Snap Auto. The Firebolt Inc. is a machine learning / AI company that basically does machine learning for humans. So it uses machine learning to improve human lives. For example, one of the projects I'm working on in Firebolt right now is called Project Aurora, which is scheduled to be the first beta version is scheduled to be released in around July of 2022. So Project Aurora is basically a way of an online website, which I'm developing right now, where it can predict cancer.
Mm-hmm.
So, for example, if you don't know if you have skin cancer or not, take a photo of that piece of skin that you think that might have skin cancer and upload it to Project Aurora's website. And then it's going to tell you if you have skin cancer or not. This is one of the things that I'm working on at Fireball.
Okay.
And Snap Auto is basically a company which focuses on autonomous stuff. Anything that's autonomous.
Okay.
Like, for example, flying cars, autonomous vehicles, robotics, anything that's autonomous, because I love autonomous stuff.
And is it kind of just you working on this, or do you have a team working with you on these companies?
On Snap Auto, I'm the only person, because not a lot of people know self-driving cars, flying cars, or robotics.
Okay.
Which is a problem.
So
I
absolutely.
can work on it myself. But for Fireball Incorporation, I have a team. So I have my dad, me, and also one of my friends.
Very cool. Very cool.
Thank you.
Well, Aaron, once again, thank you so much for taking the time to chat with us, and congrats on all your accomplishments in machine learning. You really are an inspiration to folks that are interested in this field and learning. There's so much to learn here. Thanks for everything you're doing.
Thank you. Also, right before I leave, I have some acknowledgments I want to say.
Oh, please.
Okay, first of all, I'd like to thank Sebastian Witalik, Sebastian Thrun, Vienna Harvey, David Silver, Lawrence Morney, and also Sam Charrington. And also my family, who's been really supportive. And also much more mentors. And I'm really blessed to work with all of you. Thank you.
Awesome. Thanks so much, Aaron.
Thank you.
All right, everyone, that's our show for today. To learn more about this episode, visit TWIMLAI.com. Once again, if you missed TWIMLCon or want to share what you learned with your team, be sure to visit TWIMLCon.com/videos for more information about our video packages. As always, thanks so much for listening, and catch you next time.